In this video, we're going to look at 3 common topics you're going to see on the ALEKs math placement test and how to properly solve. We have to remember that this exam is not multiple choice, so our final answer is going to be the answer that's graded. So in a problem like this, we're dividing by a radical expression. We can't have radicals in the denominator, so we have to multiply by its conjugate to cancel it out. The conjugate is just the same radical with the opposite sign. So 5 plus radical 2, we do the same thing to the top. Now, let's focus on the bottom because that's easier to multiply. When we look here, this is like the difference of squares. So we just multiply the first 2 terms and the last 2, and what we're going to get is 25 minus 2. Now, on the top of this expression, we're going to FOIL. So after I FOIL, I'm going to have 25 plus 5 radical 2 plus 5 radical 2 again. And then when we multiply those last terms, it's just going to be plus 2. Now I simplify my expression by combining. So I'm going to have 25 and 2 to get 27. We combine 2 radicals right in the middle to get 10 radical 2. And then on the bottom, after we subtract, we're going to get 23. Now as we look at this final answer, we cannot simplify these terms because there is not a common factor. And with that, we're going to go on to our second topic of this video. Second topic, we're going to be dealing with fractional exponents, aka exponential exponents. And they want us to take this expression and put it in radical form. So what we're going to need to do is use the properties of exponents and find a common denominator for that quotient rule. So once I multiply my top exponent by 4, we're going to get z to the 4 over 12 power. And then once we do the same thing to the bottom, change the denominator, this is what we're going to get. First expression turns to z to the 3 over 12 power multiplied by z to the negative 9 over 12 power. Now there's 2 ways that we could solve this, family. We could combine the denominator, then simplify the fraction, or we could treat this as 2 separate fractions, then combine. I'm going to do the first method because I think that's easier. So down here, right, we know the top is going to stay the same because we're not doing anything to it. And what happens on the bottom is I'm going to add these exponents. So when I add my exponents, I'm going to get z to the negative 6 over 12 power. Now at this step, I could do my quotient rule and subtract my exponents. So if I take this down here, I'm going to have z to the 4 over 12 minus negative 6 over 12. So this turns into addition. And now when we simplify, I'm going to get z to the 10 over 12 power. If I simplify my fraction one more time, I'm going to get z to the 5 over 6 power. And if we want this in radical form, now that's the most important thing. This is right, but if we don't put it in radical form, it's wrong. So we know we're talking about base of z. And then when we look at this, we're going to have to the power of 5 and a root of 6. And this should be our final answer in how to properly solve. And with that, let's go to the last topic. Last problem of this video, we're talking about radical equations. And if you have found this review helpful, just smash the like button for us. Comment down below, let us know. So we're dealing with radical expressions. And the first thing we want to do is get rid of the radical by squaring both sides. All right. Now, the reason why students get this wrong is because they incorrectly square this side. This turns into y minus 3 times y minus 3, meaning we are going to get a trinomial. We're not going to square this to get y squared plus 9. No. So this turns into y squared minus 6x plus 9. And now on the other side, that exponent cancels out our radical for us to get negative 3x plus 63. Now at this step, we're going to combine and factor. So I add 3x on both sides. Now what I have is y squared minus 3x plus 9 is equal to 63. Now I subtract 63 on both sides. We have y squared minus 3x minus 54 is equal to 0. Let me double check to make sure I added right. Yep, that's correct. Now at this step, we are factoring. This is what we're factoring. And when we factor this, this is going to turn into y minus 9 times y plus 6. And this is equal to 0. So at this step, y minus 9 is equal to 0. So y is equal to 9. Or y plus 6 is equal to 0. So y is equal to negative 6. Now, if you want to get this completely correct, we have to check for extraneous solutions. Just saying this, we're going to get it wrong in this exam. So let's plug in 9 first. And we're just going to plug it into the original equation. So let's switch back to blue. So right here we have what? 9 minus 3 is equal to the square root of negative 3 times 9 plus 63. So when I simplify, right, this is 6. When we go over onto the other side, what are we going to get? Negative 27 plus 63. So we're saying 6 is equal to the square root of, and let me look back down at my calculator real quick. Sorry, guys, I did get a little lazy. All right, we're going to get 36. So now we're saying 6 is equal to the square root of 36, which is 6. That is correct. So we know y is equal to 9. That is an answer. That's an answer. It's not an extraneous solution. Now we're going to go back and check our other factor. So now I erase this, right? And let's go back and check now. So now we're saying negative 6 minus 3 is equal to what? The square root of negative 3 times negative 6 plus 63. So now we're saying negative 9 is equal to the square root of 18 plus 63. Negative 9 now is equal to the square root of 81. So now we're saying negative 9 is equal to 9, and that is not correct. So we know this would be an extraneous solution. Y is equal to negative 6, and our correct solution that satisfied this equation is y is equal to 9. So when you take your ALEKs math placement test, make sure you guys practice showing all your steps and getting to your final answer. And like I said, hope this video review was helpful for you all. If it was, smash the like button for us, comment down below, and let us know if you want to see future videos on our math channel or if we should make more ALEKs math placement test exams. Thank you guys so much for joining Algebra 1 with Mr. Peters.